In lesson 5.2, our major learning targets are primarily we're just focusing on evaluating roots of numbers, which are expressed typically as radicals. And so we're going to learn how to take a radical and simplify it. Not get a decimal approximation, but simplify that radical. In addition to this, we're also going to learn how to remove a radical from the denominator or bottom of a fraction and move it up to the numerator or top of the fraction. So we're going to start with an example where we're just asked to identify the simplest radical form of the square root of 8. Now there are a couple ways to go about doing this. I'm going to start with the method that I prefer, which is we want to figure out in that number under the radical 8, is there a perfect square that divides evenly into that number 8? A perfect square is a number like 2 squared, which is 4, or 3 squared, which is 9, or 4 squared, or 5 squared, or 6 squared, and so on. Clearly, I'm going farther than I need to for this particular problem. But when I think about the number 8, it is evenly divisible by 4. So I can think of the square root of 8 as the square root of 4 times the square root of 2, because 4 times 2 is 8, therefore square root 4 times square root 2 is square root 8. Well, why did I do that? Well, because the square root of 4 is a perfect whole number. It is the number 2. So when we take the square root of 4, we get the number 2. Now when you take the positive square root, which is what we will be always doing when we're simplifying a radical, when you take the positive square root of that radical, you have found what's known as the principal root, just a term that's used in our textbook. So the square root of 4 has simplified to 2, but that square root of 2, that is not a perfect square underneath the radical. So if we were to hit square root 2 on our calculator, we would get decimals, and we don't want decimals. So we just leave it as square root of 2. Therefore, square root of 8 simplifies to 2 square root 2. So let's try that method again. Let's say we want to put into simplest radical form the square root of 45. Again, we want to find the largest perfect square that divides evenly into 45. Well, clearly it's got to be a number less than 45. 36 doesn't divide into 45. 25 doesn't divide in evenly to 45. 16 doesn't, but 9 does. So we can break apart the square root of 45 into the square root of 9 times the square root of 5, because 9 times 5 is 45. Well, the square root of 9, the principal square root of 9, is 3, and root 5 is a decimal, and we don't want a decimal if the directions say simplify. So our simplified radical is just 3 root 5. Now in this third part of the example 1, now we're dealing with a cube root. So a cube root is finding a number that when we multiply it by itself 3 times, we get 24 in this case. So we don't want a list of perfect squares, but rather a list of perfect cubes. So 2 cubed is 8, so 8 is a perfect cube. 3 cubed is 27. 4 cubed is 64, and so on. So once again, I want to find a perfect cube this time instead of square, a perfect cube that divides evenly into 24. And the largest perfect cube that does so is the number 8. Therefore, I'm going to break apart the cube root of 24 into the cube root of 8 times another cube root. Well, how many times does 8 go into 24? It goes in 3 times. So cube root of 24 is the same as cube root of 8 times cube root of 3. The cube root of 8 is 2. because if I multiply the number 2 by itself 3 times, I get the number 8. Now with cube roots, they only have one possible value, because the cube root of 8 cannot be negative 2, because negative 2 times itself 3 times is actually negative 8. So negative 2 is not a cube root. So there's only one cube root of 8, and it is the number 2. So the cube root of 24 simplifies to 2 times the cube root of 3. We don't do anything more with the 3, because if we did, we found the cube root of 3, it is a decimal. If the directions say to simplify, we don't want a decimal. So the final part of example 1 is asking us to put into simplest radical form the cube root of 54. So again, we want to look at our list of perfect cubes and find the largest one that divides evenly into 54. Well, obviously it has to be smaller than 54 or equal to 54, so we can rule out 64. 27 does go into 54 2 times. Therefore, the cube root of 54 can be broken out to the cube root of 27 times the cube root of 2. And we know that the cube root of 27 is 3. Therefore, this simplifies to 3 times the cube root of 2.